welcome back. In our last video, we illustrated the rule of 72. In this video, we're going to use a spreadsheet to build a future value table. And then from the table, we're going to illustrate how the rule of 72 evidences itself. Okay, so we're looking at a blank spreadsheet here. You can access a spreadsheet by going to docs.google.com and then choose Sheets and choose to open a blank worksheet. In cell A1 here, I'm just going to enter the number 1 and hit enter. I've got it pre-formatted, if you will, as a dollar value. Basically up here is where I can do my formatting. And then across the rows, I'm going to start here with 1. I'm going to type in the number 2. And I've got this row 2 formatted as a percent. By just clicking on 2, clicking percent, it formats all the values as a percent. Now notice I'm clicking away. I'm going to click on 1 and hold, and I'm going to move over to where 2% is shown and let go. Now I'm going to drag the circle that's in the lower right corner all the way out to the right. So you can see my table is going to have interest values from 1 through 12%. So similarly, on the left, I'm going to enter 1. I'm going to arrow down or hit enter. I'm going to type 2 in the next cell. Then I'm going to hit enter. Then I'm going to click and hold number 1. And then I'm going to move the cursor down to the cell that shows number 2. And then I'm going to let go. And now this circle reveals itself. I'm going to grab it and I'm going to drag it all the way down so that I have 50 years worth of growth, basically. All right, so now we've got the structure of our spreadsheet set up. Okay, the next thing I'm going to do is zoom in a little bit to make everything easier to see. So I'm just going to jump in here and go to 150% zoom. So if you remembered from your math and your science, in order to get a number growing, there's a formula that's basically takes the current value and multiplies it by 1 plus r, the rate of growth, raised to the power n, or the number of years. So we're just going to reconstruct that here. So I'm just going to type in equals. The program's going to make a suggestion to me that I don't want to use, so I'm just going to X out of that. So anytime you want to start a spreadsheet cell with a formula, you've got to type in equals or press the equals key. So what I'm going to do here is say, I don't want to take this sum, whatever this sum is that I may enter in the change in the future. I want to take that sum there and times it by, and times being the asterisk, 1 plus my r is here. Then I'm going to close parenthesis. I'm going to raise it. That's that caret to the number of years that's here. Okay. And that's pretty much it. But I want to be efficient here. And one of the things I want to be able to do with this formula is to drag it over to the right and then drag it all the way down and populate the whole table with it. So what I'm going to do is I've got to lock in what we call lock-in references. For example, a spreadsheet is very sophisticated in that it is looking to the initial value that I want to grow by saying move 1 cell over and 2 above, and that's where it is in position to this cell. Well, the problem is, again, if I drag everything over, the references are going to continue to move. So what I want to do here is I want to lock in the A, and you do that by entering a $sign. And also I want to drag this whole formula down as well. So I want to lock in basically row number 1. So I'm locking in both there. Now, when we next get to B2, that's where we show our percent. We want the percent changing as we drag the formula to the right. But again, as we drag the contents down, we don't want that moving. Our formulas are only shown on row 2 here. So I'm going to lock in the value 2. And then here, my years are only shown in column A, so I'm going to lock that in. So here I go. I hit enter. Again, the program makes a suggestion to me, which is not bad, but for now, we're just going to leave it alone. So now what I'm going to do is I'm just going to go back. I'm going to see if I can fit in all 12 rows here. And I'm going to take this, drag it out to the right, and let go. Then I'm going to drag it all the way down to my 50 years. And voila. I've built a future value interest table. Now, while I have this highlighted, want to do something here. I'm going to format, and I'm going to do something called conditional formatting. So for every cell in this area, I'm going to format it differently if the value is between. Okay, so I'm going to say that the value is between 1.95, let's say, and 2.05. Now, why am I doing that? For this reason. I have a single dollar. Remember, the rule of 72 says that a combination of number of years down here and rate of interest across here, when that combination multiplies to 72, we will double our money. Well, in order to double a dollar, we basically are looking for in the table for $2. So you can see what's happening out here, guys. It's kind of interesting. Uh, Here, it's kind of follows a nice little pattern, a nice little arc as it moves across the table. So, for example, there was 9% at 8 years. Here is 8% at 9 years. Here, relatively close. Again, $1.97 is 10 years at 7%. But notice those would just multiply to 70, 10 times 7. So it's just shy of 72. And if you look here, this is just shy of doubling our dollar. Next, what I'd like to do is move to the left and down the table, but I don't want to lose the visibility of the percentages shown across row 2. So what I'm going to do is click row 2. I'm going to click View, then Freeze, and then up to 2 rows. So what's going to happen now, as I scroll the cursor down, you'll notice these 2 rows are frozen on the screen. Why am I doing that? It's here that the rule of 72 falls apart a little bit, if you will. Notice between years 23 and 24 at 3% rate of return, we don't really have an exact $2 number there. And then if we go further down in the column showing what your money will grow to if grown at 2%, you can see I've got 3 values that are pretty close to 2. In fact, the one that is actually at exactly 2 is at 35 years, but 2 times 35 is only 70. Now, before we wrap up, I do want to point out that there was financial planning in the days before these amazing computers and spreadsheets arrived. Imagine a financial planner taking a printed version of this spreadsheet to a client and telling the client, for example, if you can invest, say, $10,000 for 50 years, earning 12%, it's a bit of a reach, but not undoable, 12% per year. You'll have 289 times, if you look at the number in the bottom right corner, 289 times the amount you invested. Why? Because in the upper left corner, we have 1, and then in the bottom right corner, we have 289. So here, of course, we can do one better. We can type in the sum of 10,000 and hit enter, and the spreadsheet populates, and we can see that that sum will grow to $2.89 million. We are back. Thank you so much for joining me on this journey through spreadsheet construction. If you've learned a few things and enjoyed the video, please like it, share it, and of course, subscribe to the FinanciaLit channel. Till next time.